Hey everybody, and welcome to How-To Videos with Dr. Amy Gates. This video is going to focus on how you can see and evaluate the shape of a distribution by using a histogram that you create in StatCrunch. So what we have here to start off is we have a relatively small data set made up of ID, age, the year in school, the gender of a student, their GPA, their final exam score, and the number of classes that they've completed. So that's our overall data set. Some of our variables are qualitative, like ID. This is a qualitative variable, it's just a quality. These are not real numerical values, they're just ways of identifying students without using their names. So ID is qualitative, it's discrete, and it's nominal because there's no order to these values either. This student is not larger than that student, for example. We have other variables like age and GPA, which are continuous quantitative variables, and so on. And so all of the data that we have under each of these variables has its own distribution or shape. And the word distribution is kind of a fancy word, but all it means is how is the data distributed? Is it mostly large numbers? Is it mostly small numbers? Is it a fairly even range? Is it normally distributed, meaning does it have a bell-shaped distribution? Is it bimodal? Is it a skewed distribution? And so on. So oftentimes you'll need to know the shape of your data or how it's distributed. And one of the best ways to determine the shape of your data or how it's distributed, its distribution, is to create a histogram for that data set. And of course, the larger your sample size, the better your histogram will show you the overall distribution of the population where that data came from. Because remember, this is a sample of data, but there are many students in the world. And so all the students in the world would be our population. This is just a sample of that population. So let's say we're wondering, what's the distribution of our age? Do we have mostly young students, mostly older students? Do we have a fair range? Is it bimodal? Is it skewed? To figure out the distribution of any variable, we're going to use a histogram. So we'll click on Graph, we'll choose Histogram, and then when the box pops up here and asks you which variable you want, in this case, I'm just going to choose age. Remember, when using StatCrunch, if you want to select more than one variable, let's say you're making a calculation and you don't want to do it over and over, you just want it to do all the variables at once, you can hold down either the Control key if you're using a PC or the Command key if you're using a Mac that's on your keyboard. But I don't need to do that because I just want to look at the shape of the distribution for my age variable. And I don't need anything fancy because I'm not looking at just the age of females or anything like that. All I want is the shape of the distribution of my age. So I'm just going to click Compute, which is here at the bottom. When I click Compute, StatCrunch creates for me a histogram, and I'll scooch it over here so we can see the ages while we look at the histogram. This is a distribution of all the ages in our sample. And we can actually see visually that this is very accurate. It's telling us that we have only one person that's between 70 and 80 years old. And if we scan this data set, we can find them. There they are. This person's 78. But it's the only person in our data set that's that age. And so that's what they're telling us here, that between 70 and 80, we have one person. It's also telling us that between age 60 and 70, we actually have two people who are that age. That's the frequency. Histograms are frequency distributions. They tell you how many values in your data set are between a certain range. In this case, between 60 and 70. So we can find those two people. Here's one of them, that person's 63. And if we keep scanning, here's the other one, that person's 61. And that's it. We don't have any other people in our data set who are between 60 and 70. So there's two people in that group. There's also two people between 50 and 60, two people between 40 and 50, but you see we have 6 people between 30 and 40, and we actually have 7 people between 20 and 30. So this shows you the shape of the distribution of your ages in this particular sample. Now this is definitely a skewed distribution, right? It's right skewed. It's skewed to the right. And so you have more students between 20 and 40. Look at all those students between 20 and 40 than you do between 40 and say 60. Many more students between 20 and 40 than between 40 and 60. So this is an example of a skewed distribution, and it describes the ages of the students in this particular sample. Now let's check out another one. Let's say we're curious about the GPAs of our students. How's the GPA distributed? What does it look like? Is everybody having an A average? Is everybody having a low average? Is it balanced? Is it normally distributed? Let's find out. So again, we click on Graph and Histogram. And in this case, we're looking for GPA. So I'll choose GPA, then I'll select Compute, and again I get a histogram that describes the GPA of all of my students. Now this histogram looks very different than the last one. It's relatively symmetrical. Given a sample, you're not going to ever have a perfect bell-shaped curve. You don't want to expect that. But this curve is actually very symmetrical. It has a bell shape to it. We have one student who's got a GPA between 1 and 1.5, and we have one student with a GPA of 4.0. Here's our 4.0 student. Here's our student with 1.25. So we've got these two students. And then we actually have a couple students between 1.5 and 2, and we have 3 students who are actually between 3.5 and 4, and we can find those as well. And the majority of our GPA scores are actually between 2 and say 3.5, if we look very closely at this. So this is a relatively bell-shaped curve. It's relatively symmetrical. And so the shape of this distribution, you could guess, is maybe even normally distributed. It has a lot of characteristics of a normal distribution, where the majority of the scores are near the mean or the center. Very few of the scores are near the ends, and overall the shape is symmetrical. So again, this looks normally distributed. And let's one more. Let's say we want to look at final exam scores. How are the students doing in this class overall? Again, we'll click on Graph, we'll click on Histogram, and then here we're going to choose the final exam, and we will click Compute. So in this case, we have a very different distribution than we had in the other two examples. This one is actually called bimodal. So in other words, it has 2 different areas. So it has a fairly large number of students who got final exam scores between, say, 65 and 75. And then it has another group of students who actually seem to be somewhat evenly distributed between an 80% and a 100%. So this is not symmetrical. It's a little bit skewed to the right. Even though it's missing data here, it does have a right skew. And it may in fact be bimodal data in the sense that it has 2 almost separate groups of students. We have the first group, and then we have a separate second group. So definitely skewed, definitely bimodal, not normally distributed, and not symmetrical. So anytime you have a data set and you want to evaluate the shape of the distribution to get more information about that data, you can use StatCrunch to create a histogram, and then you can visually analyze that histogram to make assumptions or assertions about that data set and maybe the underlying population. Thank you very much for joining me.